Good day, my name is Rabi Olalire. So today I'll be taking us on equations of uniformly accelerated linear motion. The equations of uniformly accelerated linear motion. So let's see what we have in the topic. Now, when we say acceleration, acceleration is actually the rate of change is the rate of change of velocity with time. When a body changes its velocity with time, then that rate of change is what we refer to as acceleration. So it is the rate of change. So as you can see here, rate of change of velocity with time. The SI unit of acceleration is meter per second squared. Meter per second squared. So mathematically, we say acceleration is change in velocity, theta v, over time. So if A is acceleration, the change in velocity is given as v minus u. V is the final velocity, that is the velocity of the body after some time. Then the initial, that is the velocity the body is starting with. So v minus u over t is what we call acceleration. Now, when we say acceleration along a straight line, linear acceleration, we are talking about acceleration along a straight line. So what we are looking at today is acceleration along a straight line. So a body can only accelerate when its velocity, take note of that. So it is only when there is a change in the speed or the velocity of a body that we say that the body has accelerated. So there must be a change in the speed or velocity before you can talk about acceleration. A body has zero acceleration. You can see that when the velocity is constant in both the magnitude and direction. We say that velocity is the vector quantity. Velocity is both magnitude, has both magnitude and direction. So it's the vector quantity. So in order for acceleration of a body to be zero, then the velocity must be constant. We say before there can be acceleration, there must be change in velocity. So if there is no change in velocity, either in magnitude or in direction, then definitely the acceleration will be zero. So that's what that statement is saying. Now, when a body is in uniform motion implies uniform speed or uniform velocity. That's the meaning of uniform motion. So if a body moves if a body is in uniform motion along a straight line, then the acceleration of the body is zero. The acceleration is zero if the motion is along a straight line and the speed or velocity is uniform, magnitude and direction uniform, the same, constant, does not change, then we say the acceleration of such a body is zero. Now, a body can still move with uniform speed in a circular motion, although the speed is uniform. Speed is magnitude of velocity, so it is the magnitude that is the same, but the body still has an acceleration, and that is under circular motion. That is what we refer to as centripetal acceleration. So the body still has acceleration, and that is because the direction of the velocity changes. That is why a body in a circular motion, despite the fact that the speed is constant, the acceleration is not zero. It still has an acceleration, and that is because of the direction of the velocity that is changing with time. I believe you understand that. Now let's look at the next thing here. Equations of uniformly accelerated linear motion. So we have just four of them. The first one is this: S equals to U plus V over 2t. The second one is V equals to U plus 18. The next one is V squared equals to U squared plus 2AS. The next one is S equals to UT plus half AT squared. So those are the equations of uniformly accelerated linear motion. So the equations are only applicable to a single acceleration. We have some question in which the motion will be divided into stages. So in such, you cannot use this equation. So you can only use it for a single acceleration. So we have 5 letters or symbols that are used in the equation. So what does those symbols or letters, what do they represent? V represent the final velocity and the unit is meter per seconds. The unit is meter per seconds. U, the letter U there is the initial velocity and the symbol is, the unit is meter per seconds as well. The initial velocity, the velocity the object starts with. V, final velocity, the velocity after traveling sometimes for some time. A is the uniform acceleration in meter per second squared. The uniform acceleration we are talking about in meter per second squared. Then the fourth letter is S. S is the distance traveled, although some may use X, some may use letter X instead of S, so it's still the same, but what is mostly used is S for O level. Then T is time in seconds. So those are the 5 letters U, V, A, S, T, which I sometimes call UVAST. 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 Do you understand that? So now let's see what are those things that you need to take notes in using these equations. Let's see. The following should be noted while solving problems of this type. Number 1, the initial velocity U is 0 when the body starts from rest. So take note of the word rest when you are solving question on this. Are you with me? Good. So when the body starts from rest, then we say the initial velocity U is 0 meter per second. 2, the final velocity V can also be 0. That is when the body stops or when the body comes to a complete halt. When the body comes to a complete halt, then we say that the final velocity V is 0. U is 0 when the body starts from rest. V is 0 when the body stops or comes to a complete halt. Then 3, the acceleration is negative for a body that slows down. When the body slows down, that means the velocity decreases. Or when a car applies its brakes, when a car applies its brake, the velocity decreases. So if the brake is applied to bring it to a halt, it may not even come to a complete halt, but once the brake is applied, there is a deceleration. So it is the negative acceleration that we call deceleration or retardation. I take it again. The negative acceleration is called deceleration or retardation. So to solve calculation questions on these equations we have talked about, these equations that we have here, to solve questions on them, then we have to firstly write out the parameters that we are given. So that's what will guide us into the question, to the particular question, the solution to the particular question at hand. Do you understand what I'm saying? Now let's move to the next slide. Okay, this is 2020 Y question number 30. The question says, a motorcycle starting from rest is uniformly accelerated such that its velocity in 10 seconds is 72 km per hour. What is its acceleration? Option A is given as 108 meter per second squared. Option B is 86 meter per second squared. Option C is 4 meter per second squared. Option D is 2 meter per second squared. So just like I said, it's on uniform acceleration. So firstly, we write out the parameters. So the parameters given are, number 1, we're given U. So U is 0 meter per second squared. So that is because the body starts from rest. So we said that when the body starts from rest, the initial velocity is 0. So U is 0 in this case. So U is 0 meter per second. Do you understand? Okay, now I can move on. We're given the time, 10 seconds is the time. Then we're given the final velocity, 72 km per hour. 72 km per hour. So the question says we should calculate the acceleration. So this is U. U is given to be 0, T is 10 seconds, V is 72 km per hour, and A is acceleration. Now the SI unit of velocity is meter per seconds, not kilometer per hour. So this 72 kilometer per hour must be converted to meter per seconds. So how do we do that? We multiply the 72 by 1000 and we divide by 3600. I take that again. To convert kilometer per hour to meter per seconds, which is the SI unit, we multiply this value by 1000 and divide by 3600. So the velocity here is 72 km per hour. So multiply by 1000 divided by 3600. We are going to have 20 meter per second. So we are making use of 20 meter per second as the final velocity here, and we are looking for the acceleration. Now, based on those four equations, I wrote the four equations here. Based on what we have u, we have t, we have v, and we have a. So we have u, v, a, t. So let's see. A is not here, so we cannot use this. So this is out. So we have u, v, a, t. U, v, a, t. Exactly what we needed. So we are picking this. So we pick this. So that is why you have it here. Then we substitute. V is 20. So we have 20 equals to u is 0 plus a multiplied by 10. So this is the same as 0 plus 10a. So 0 plus 10a is 10a. Then to get our a, we divide both sides by 10, which is the coefficient of a. So when we divide both sides by 10, we have 2 meter per second squared. So the correct option is D. So D is the correct option here. So our answer is D. So 2 meter per second squared. So that is the acceleration of the body. Do you understand that? Now let's look at the next question. This is WAEC 2017 question 3, 2007 question 11. So the two. So the question says a body accelerates uniformly from rest. Take note of the word rest again. When the body starts from rest, what does it imply? Good. The initial velocity is 0. So u is 0 at 2 meter per second squared. What does this represent? Yes, this is our acceleration because of the unit meter per second squared. That's the unit of acceleration. So the acceleration is meter per second squared. Calculate the velocity. So we are looking for the final velocity when it has traveled a distance of 9 meters. So option A is 3 meters per second. Option B is 4.5 meters per second. Option C is 6 meters per second. Option D is 18 meters per second. So we write out, firstly we write out the parameters given. The parameters given is u 0 meter per second because the object is starting from rest. Then we're given the acceleration a as 2 meter per second squared. We're given the distance s as 9 meter, and we are looking for v. So we go back to those equations again. So we have the equations right here. So which one are we going to choose? Let's see. We are looking for the one that has u a s v. Again, u a s v. So that is the one that does not have t at all. This one has t, so we cannot use this. This is out. This is out. Good. This is the correct one we are picking. So we are using v squared equals to u squared plus 2as. So we substitute. We are looking for the final velocity v. So we have v squared equals to our u is 0 squared plus 2. A is 2. 2 times 2 times 9. 2 times 2 times 9 will give us 36. So 0 squared is 0. 0 plus 36, we have 36. So taking the square root of both sides to get our v, square root of 36 is 6 meter per second. So the correct option is C, 6 meter per second. So that is our velocity. Do you understand that? So that's the velocity of the car. Do you understand that? Now let's look at the next question here. So this is WAEC 2014 question number 10. 2014 question number 10. The question says a car accelerates from rest. Take note of the word rest again. What does it mean? The initial velocity is 0. Very good. Covers a distance of 40 meters in 10 seconds. Calculate the magnitude of its acceleration. So the options are 0.25 meter per second squared, 0.80 meter per second, 3.20 meter per second squared, 4.00 meter per second squared. The first thing is what? We write out the parameters. Good. So the parameters are u is 0 meter per second. That is because the object is starting from rest. S is 40 meters. T is 10 seconds. Then we are looking for the acceleration. So we go back based on what we have. USTA. A is not here, so this is out. USTA. S is not here, we cannot use this. USTA. T is not here, we cannot use this. So this is the best. So this is the one that will work for this question now. So substituting, so we are using S equals to UT plus half AT squared. So substituting, S is 40, U is 0 multiplied by T is 10 plus 1 over 2 times A is unknown, then T is 10 squared. That is, so we write 40 equals to 0 times 10 is 0 plus 1 over 2 times A times 10 squared is 100. So we have 40 equals to 0 plus 50A. 0 plus 50A is 50A. So dividing both sides by the coefficient of A, which is 50, we have A to be 0.80 meter per second squared. So the correct option is B. So B is the correct option here. So we have B. So B is the correct option. Correct option is B. Do you get that? So those are the questions we look at for today. But for practice questions, just try some of these questions here. So I have some questions here you can try. So just try these questions here. A moving body accelerates. A says changes its direction at constant speed, maintains a constant linear speed. C says covers equal distances in equal times in a straight line. Is acted upon by balance force. So this is WAEC 2014 question number A. The correct answer is option A. You can refer to the note. We said the body will accelerate when at constant speed. If the speed is constant, then the direction must change. If the body will accelerate, we said that in the note. Then question 2, so you can try some of these questions. And if you still have any question, you can send to me in the comment section. Thank you. So you can see some of the past questions. Then you can also check some of these questions out. These are some questions you can check out as well. So check some of these questions out as well. If you have any question, you send to me in the comment section. So thank you. So that's the end of the class. Thank you.